Alright, in this video I'm going to be talking about what is the difference between 8, 16, 32, and 64-bit. To understand what the difference between 8, 16, 32, and 64-bit is, you must first understand the hierarchy of languages. What is the hierarchy of languages? Computers understand languages. Those computers can be divided into two categories, high languages and low languages. For example, let's say your name is Bob and I asked you to write your name down. You're probably smart enough to know to grab a pen and write your name on some paper, so you would be able to do that if I asked you to do that. When I asked you to do that in just 3 words, right? All I said to you was write your name and you knew what to do. Now let's say, for example, you weren't that smart and I have to say, Bob, I want you to find a pen and a piece of paper and write down on that paper, write your name down on that paper with that pen. I've effectively asked you to do the exact same thing, but I'm expanding on each task to make it easier for you to understand. I can keep expanding on every task until I get to a point where I'm saying, Bob, get up, walk to the desk, use your right hand to pick up the pen, place the pen on the paper, draw a B, then an O, and so on and so forth. This is called the hierarchy of languages. At the top, language is concise and not descriptive, but we can go down to the hierarchy until we're at the bottom, and every tiny aspect of a task is mapped out in extreme detail. This is how computer programming works. I write a program with a high-tier language like Java or C, and when I compile that program, the computer gives me a file in a lower-tier language. It's still exactly the same program, just more descriptive. This helps ensuring I don't have to write 1,000 lines of code just to simply print "Hello World." At your lowest tier, you have super simple commands. Add 5 to 6, store the result here, retrieve this number, and 23 with 67, add 23 with 67. These can be called code words or instructions. These are the literal commands that your CPU processes. For example, when you play Borderlands 2, all your CPU is effectively doing is adding numbers together billions of times a second. The reason we have the hierarchy of languages is because code words are the only language CPUs understand, and no programmer wants to write a complex program using only instructions, so computer scientists have invented more complex languages to translate up the hierarchy to make programming easier. So how does this all relate to the question of what is the difference between 8, 16, 32, and 64-bit? Code words are the only language CPUs understand, and the length of these code words determines the complexity of your computing ability. A code word of 4 bits can hardly do anything, but a 16-bit CPU might be able to do basic math or play some very simple games. Up until recently, most home PCs had 32-bit CPUs, meaning that the code words they processed were 32 bits long. Now we're moving into 62-bit code words. With those extra 32 bits, we can have bigger numbers for memory, so we can access more and make use of larger amounts of RAM, and we can add more complex functions to the computer itself. This doesn't necessarily make the computer faster, it just opens up new avenues for how to make the computer run. Perhaps simply in more efficient ways. When you define all the possible functions a CPU can perform, this is called an instruction set. A 64-bit CPU has a larger, more complex instruction set, meaning you can do cooler stuff if you use it. Unfortunately, it also means you have to write down your programs you have to write your programs to take advantage of it. This is why some programs come with both 32 and 64-bit version. One makes use of the new set, meaning it might run better, but a poor programmer had to spend a lot of time transferring it to the new set. In essence, it means this. 32-bit means that your CPU reads 32-bit instructions. 64-bit means that your CPU can read 64-bit instructions. Since 64 bits are bigger, you can do more stuff with them, meaning that the program might run better. Another way to explain it. The bits are like a highway. 32 bits mean that you have 32 lanes on a highway. 64 bits mean that you have twice as many lanes. The lanes are what carry your data around your machine. Between the CPU, RAM, and motherboard, etc., it's also how much data the CPU can access at one time. That doesn't mean it's faster, just more accurate. For things that use tons of data like Science Lab, movie studios, the extra room does make processing faster. On your average home machine, you won't notice much of a difference. 64-bit software is made to take advantage of the extra room and can't run on 32 CPUs where there's not enough room. 64-bit CPUs can run on 32-bit 64-bit CPUs can run 32-bit software, though, even some 16-bit software. And here's another way to explain this really weird, stupid concept. In computing, 32-bit and 64-bit are two different types of processors. The bit number, usually 8, 16, 32, or 64, refers to how much memory a processor can access from the CPU register. Most computers made in the 1990s and early 2000s were 32-bit machines. A 32-bit system can access 232, what is that? 4,294,967,296 memory addresses. Practically speaking, a 32-bit computer is limited to accessing that many bytes, 4 gigabytes of RAM. Since most computers released over the past 2 decades were built on 32-bit architecture, most operating systems were designed to run on a 32-bit processor. Around 2008, 64-bit processors became mainstream and personal computers started including 64-bit CPUs. Therefore, popular operating systems such as Windows and Mac OS X began shipping in both 32 and 64-bit editions, which allowed them to run either 32 or 64-bit hardware. While a 32-bit processor can access 332 memory addresses, a 64-bit processor can access 264 memory addresses. So this is not twice as much as a 32-bit processor, but rather 232, so on and so forth, times more. This means that a 64-bit machine could theoretically access, however much that is, memory addresses over 18 billion gigabytes of RAM. However, as of 2013, there are few computers that can physically support more up to 64 gigabytes of RAM. While many 32-bit programs can run on 64-bit operating system OS, 64-bit programs are not compatible with 32-bit operating systems. Additionally, many 32-bit drivers and system utilities are incompatible with 64-bit systems. Therefore, when purchasing or even downloading new software, it is important to know if it's 32-bit or 64-bit OS is installed in your computer. So there you go. That's what it is. It sounds to me like the difference between 32-bit and 64-bit is I like the freeway analogy. That I think is a correct way of saying it. It's basically test. It's basically the infrastructure, the roads of which data goes through your computer, right? It's the freeway. It's the a freeway that has 64 lanes instead of 32 lanes. You're gonna be able to pump more traffic through. It's as simple as that. So pump more traffic, pump more data. And there you go. That's what the difference is between 8, 16, 32, and 64-bit is.